Okay, these are your Chapter 3, Section 3 notes. We will only be doing half of it, so this will be part 1. We're going to get through these first 3 objectives here. We'll save these bottom 2 for part 2. So first thing we're going to talk about is the atomic number. Remember, that is the number of protons that each atom has. Remember, protons identify the atom. They can't change, otherwise it changes the identity of the element. So atomic number is the number of protons. Remember, those are the positive particles. Okay, whenever you're looking for atomic number, it's going to be the large number up top. Okay, let me show you real quick for reference on what it would look like on yours. Okay, so all of these, the large number up top is the atomic number. Okay, so for boron, its atomic number is 5. For gallium, it's 31. That means boron has 5 protons. Gallium has 31 protons. Okay. All right. A couple other things though, while I got this here. This is a misconception with students. So this number right here, this 15.9994, that is not the mass number. That is the average atomic mass. That's a weighted average of all the isotopes of that element, in this case, oxygen. So it's really important to understand that this is not the mass number, that the mass number is not on the periodic table anywhere for you to see, okay? Mass number is protons plus neutrons. So for this element right here, oxygen, or this isotope of oxygen right here, the mass number would be 16, okay? Electrons can be gained or lost depending on the element. So they do not have to stay 8, but if the atom is neutral, then the protons and electrons will be equal, because remember, electrons are negative and protons are positive. So when they're equal, then this atom is neutral. If it does gain or lose electrons, that's when the atom becomes charged. But before they gain or lose, they are all electrically neutral because they have equal positive protons and negative electrons. Okay. So to clarify isotopes a little more, isotope is a vocab word, so you don't need to write that down. Okay. If you need a clear explanation of what it is, then feel free to write this down. That's kind of up to you if you need this or not. But really quick, I'm going to give you an example of an isotope. Okay, so let's just stick with the one that they're already using. So we'll just do oxygen. We've got these 2 isotopes of oxygen, okay? This one has 8 protons. Remember, if it's oxygen, it has to have 8 protons. That can't change. Otherwise, it wouldn't be oxygen, right? And like our example, this one's going to have 8 neutrons as well. This one, though, this isotope of oxygen has 10 neutrons. Okay, remember that mass number is protons plus neutrons. Well, this one's mass number is 18. This one's mass number is 16. So this isotope of oxygen has a mass number of 16 and this one 18. The difference are these guys right here, just the neutrons, okay? That's what changes the isotopes. This is called a mass number. It is not on your periodic table. That decimal in your periodic table is the average atomic mass. Very important you know the difference. Okay, so I just talked in length about mass number. It's a vocab word, so you should already have it in your vocabulary. Okay, you absolutely need to write down this slide and have an example of hyphen notation and an example of the nuclear symbol in your notes. To give you an example of how to write one for a different element, I will go back to the paint I was using, and I'll do it for this one. Okay, so for hyphen notation, we'll do this isotope first, and because they'll have different depending on the isotope. So for that first one, hyphen notation would be oxygen, spelled out, dash, and then the mass number. So for this one, it'd be 16. Hyphen notation for the other isotope of oxygen would be oxygen 18, okay? They both have 8 protons because it's oxygen. That defines it. They have different numbers of neutrons, which gives them different mass numbers, okay? The nuclear symbol for each of them, for that first one, it would be O. The mass number goes on top up high, like this, and then the protons on bottom. That's called the nuclear symbol, and I'll do it for the other one as well. So that would be the nuclear symbol for this isotope. So you must know what hyphen notation is. If it asks for it, know how to write it. And if it asks for nuclear symbol, also know how to write that. Okay, so sample problem A. If you need to pause this for a minute to look at it, you can, but we're going to determine protons, electrons, and neutrons in chlorine-37. All right. Sorry about that. All right. Chlorine-37. We need to know protons. We need to know the neutrons and the electrons. 4 protons. This is hyphen notation. That means that this is the mass number. So what I do know about chlorine is I need to know its protons. The only way to find that out is to look on here. Okay? You look on your periodic table, and here is chlorine, right here. Okay? There's the number of protons, right? The atomic number. This decimal, 35.453, is not the mass number, okay? It's very important, the average atomic mass. So just make sure, I know I've said it a lot, but it's because it's important. So chlorine has 17 protons because the mass number is 17. Okay, because right now all we're dealing with is neutral atoms, the electrons must also be 17 because it's neutral. Remember, they have to be equal in order to have a neutral charge. All right. Now, to find the neutrons, what you would do, remember, this is your mass number. It's in hyphen notation. Mass number is protons plus neutrons. That's how you get it. That equals the mass number, okay? Well, in this situation, you already have your mass number. It's 37, okay? You also know your number of protons now. So the only thing you don't know is your number of neutrons. So hopefully you can tell that you would simply subtract these two to get that. Okay, so 37 minus 17, which would leave you 20 neutrons. Okay, so that's how you would figure all that out. Okay, the last thing for this set of notes is going to be the average atomic mass. Okay, these are vocab words, you have them. You do need to write down this first bullet, though, about relative atomic mass. It's the standard used by scientists. It's a 12th of a carbon atom, basically, but you do need to write down this first bullet in your notes. This is a vocabulary word. So the second bullet you have. Also, I would write this third one in there as well. This is all good information that you will see again. So first bullet and third bullet should definitely be in your notes. Okay,